Okay, a quick and dirty experiment to show some of the things that need to be done. Here I have a bicycle spoke. I'm going to expose this area of the bicycle spoke to the edge of the rotor. I'm going to tilt the spoke in various directions, and I'm going to watch the waveforms on this Tektronix 465B oscilloscope. I'm going to take an automatic center punch. I'm going to make an indentation in the base, which will give me a bit of a ball and socket. The circuit consists of a battery case with a jumper. So I'm simply going to feed a section of the bicycle spoke with a AA battery, a nickel metal hydride AA battery. So I prepare my alligator clips. I'm going to hook my upper connections. Looks very primitive, but it seems to do the job. I'm going to use this triangle and this loop later, possibly in another video, to show you how regular this foam rotor is. This is the rotor that you've seen in a number of other videos, and it's capable of holding 8 Z-stacks. Right now it's set up to have only 2 Z-stacks, 180 degrees apart. Imperfections in this rotor caused me to choose the best set of Z-stack holes for this experiment. So I'm turning on the oscilloscope. We're going to put on some eye protection. And then some more protection. It's a full face shield. And then, if we wanted to, we could also put up a blast shield. We could hold this in front. And then down below in the corner, out of view, is a air compressor. We won't be using it at the moment because I've decided to just do this by hand, because it will show the basic principles. Alright, so I'm going to give this a quick flip. I see that I may have set up my oscilloscope, or I may have a connectivity challenge here. Okay, I'm going to make a second as so often happens in live experiments, things have gone awry. I'm going to hang this on the edge and hope that it doesn't fall. I'm going to make a second ball and socket a little bit closer. Okay. Okay, basically I'm flipping this and it's not turning particularly quickly, and perhaps you couldn't see any of that. I'm going to change the now you notice there's a very small blip on the screen. What I'm doing right now is I'm tilting the bicycle spoke. When I do this, you'll see that it affects the waveform. If I move the spoke closer, it's now at an angle but tilted toward the Z-stacks. You can see that this also creates a very small amount of EMF, probably on the order of peak to peak, maybe 3-4 millivolts. Right now, the magnets have not been field balanced. And so what we're seeing is the result of the field of the upper and lower magnets not being equal. In other words, one magnet is presenting a somewhat stronger field to the spoke.